Hi, my name is Dimitri Malsa, and in this video you will learn how to create coupled channels on the 81160A pulse function ARP generator. Why would we need coupled channels? There are some applications where this becomes essential. For example, creating IQ signals via two synchronous channels. One channel would be used for the I part of the signal. Another channel would generate the Q part of this complex signal without any skew between the two complex parts. After that, you can start adding distortions to the IQ signal, such as amplitude mismatch or quadrature error. As test setup, we have the 81160A pulse function arbitrary generator and a 9000 series oscilloscope with the vector signal analysis software running on it. Now we can start configuring the outputs for the example of IQ signal generation. To demonstrate that, I'm going to generate two different PRBS streams on the two channels, couple them, and play with the settings a little to simulate different kinds of distortions. First, I make sure channel 1 is selected. Then I press the pulse button. Here I set the frequency to 50 MHz. Set the pattern setup, pattern mode to on. Leave the pattern source at internal and select the pattern name PRBS_7. By pressing coupling, most of the parameters are copied to channel 2. I'm going to change the pattern to PRBS_9 to create a valid QPSK constellation. With these settings, I have a basic representation of a potential IQ signal. Now let's activate the channels and observe the output on the oscilloscope. In the upper left corner you see the constellation diagram. In the lower left part the RF spectrum of the signal. Upper right the arrow vector magnitude for each symbol, and lower right some statistics and the decoded signal. Now let's add some distortions to the signal. Please observe the gain imbalance value while I'm changing the amplitude on channel 1. It's going now from around 0 dB to 1 dB, almost 2 dBs of gain imbalance, while I've changed the amplitude by 0.2 volts on channel 1. The same easy way we can influence the IQ offset on this side by adding a DC voltage offset on one or on both channels. Let me select the offset control item and change the DC voltage by turning the knob. So do you see how the IQ offset is changing from -20 to -14, -12, -10, while I'm increasing the DC offset? In summary, we now know how to use the channel coupling feature on the 81160A, and we have seen an example where it can be used.